Oh, Avery, I like your top. That's very pretty. Thank you. All right, ladies and gentlemen. The nice thing is the Delta Math today is actually pretty easy. So this person who writes this stuff, Gina Wilson, you can see her name at the bottom of the page, Gina Wilson. So Gina Wilson has you doing some simplification that you really don't need to do. So I'm going to show you what you need to know here today. So the next couple of days we're doing function operations, and I think probably the hardest part is to be able to figure out domain of things. So we're going to spend most of our time talking about domain, what's it out for. So we want to be able to add, subtract, and multiply and divide functions. And then also talk about the domain, really. So addition, we have function notation here, and we can use function notation to tell us to add things. This notation is weird, okay? I did not have this notation when I was in school. Instead, we just said, hey, what's f of x plus g of x? So these two things mean the same thing. And all it's doing is saying, hey, take your f function and add it to your g function, all right? So these two statements are equivalent. And that's sort of what you want to understand here. We are not sort of distributing an x. It's not. It's just notation. So f minus g, sometimes we just simplify it to say f plus g, and it's pretty straightforward. And here we have f minus g. What does that really mean? F of x minus g of x. And what you want to be very careful of here is we're subtracting things. We might have to distribute the negative. Okay, so subtraction is going to mess everything up. Might have to distribute a negative here, so you do need to be a little bit careful. Here, this is f times g. Really, that just means, whoopsie-daisy, f of x times g of x. We're just multiplying two functions together. And then here, this is f divided by g, or f of x over g of x. And I'm going to add on a little domain restriction here. G of x cannot equal 0. Because we cannot have a 0 in the denominator, okay? Denominator domain, denominator domain. If it's got a denominator, then we have a domain restriction. So the domain of combined functions, the domain of a new function is the intersection of the two functions, the intersection of the domain, which really just means what is the smallest group of numbers, all right? It's the smallest group of numbers. It's intersection is the opposite of a union. Union joins them all together and it sort of makes more, okay? It combines a lot of things. The intersection is the things that they have in common, the overlap. So it's a little bit different. And also the domain is further restricted with a quotient function, so this one, to exclude values for which g of x equals 0. So denominator domain, we don't want that denominator to equal 0. For most of the ones today, on Delta Math, it's going to be real easy. So here we go. Example 1, we're given f and g, and we want to find the new function and status domain. And so before I even begin, I want to think about this f function here. Our f function here is x squared plus x. What's the shape of this curve? Parabola. Very good. It's a parabola. It's got x squared in it. What's the domain of that curve? How far left and how far right does it go? How far left and how far right? Infinite, yeah. Negative infinity to positive infinity. It goes forever to the left and forever to the right. We can also say that with just a bold-faced R. It means the same thing. R, that bold-faced R, means all the real numbers. All the numbers we can think of for x can be plugged into this function, okay? G is 3x minus 1. What shape is that? It's a line. It's a slanty line. It's just a slanty line. What's the domain of that slanty old line? Negative infinity to positive infinity, or simply all the real numbers. All the real number, all the values for x we could ever think of. Okay. So if I want to do f plus g, that really just means f of x plus g of x. And all we're doing is saying, hey, what's f of x? It's x squared plus x. And we want to add to it g of x. So what's g of x? Yeah, it's 3x minus 1. It says g of x is 3x minus 1. So all we're doing is substituting, essentially, and combining. Let's see what can be combined here. X squared has no friends. We've got a positive 3x also has no friends. That's it. And then negative 1 and positive 1 make a 0. So that's it. That's our f plus g function. Oh, did I forget? Oh, that's not a 1. You're right. Oh, thank you. Oh, shoot. Got my pens erased. That's helpful. Just kidding. Thank you, Brody. Okay, so now we got 1x plus 3x's is 4x's. There we go. That's better. And then minus 1. If the domain is all real numbers for both of these, and then we add them together, is it still just all real numbers? It should be. All right. Also, what's the shape of this graph? Parabola. Still a parabola. How far left does it go? And how far right does it go? Okay. So again, the domain then is just all real numbers for the domain. So for b here, this is f minus g. So that really means f of x minus g of x. And this is where we have to be quite careful. What can I replace f of x with? X squared plus x, thank you. But then we have to be very careful here because we're subtracting a couple of things. So we have to subtract all of g. So what am I replacing g with? 3x minus 1. And we need to do what with this negative? Distribute that negative. Will make life a lot easier for us. So I have x squared plus x. Negative times 3x is negative 3x. And negative times negative 1 is positive 1. So distributing that negative, and then we can combine our like terms. We got x squared. We have x minus 3x, which is negative 2x. And then we have a plus 1. Again, when I look at the shape of this function, everything that we started with was any real number. The shape of this function is also a parabola. And so again, the domain would be all real numbers. Look how laggy it is. Super laggy. Okay, question so far. Adding and subtracting totally easy. Okay. Over here, what are we doing here? Multiplying. F of x times g of x. And so f of x is x squared plus x. And g of x is 3x minus 1. And what do we have to do to multiply these two things together? Foil, yeah, we're going to foil them together. Yeah, we got to foil those together. FOIL. So let's see, I'm going to, first times first, gives me what? 3x cubed, very good. And the outside would be negative 1x squared. And the inside would be positive 3x squared. And then last times last, negative x. And so just cleaning it up a little, 3x cubed. We've got a negative 1x squared and a positive 3x squared. Gives me 2x squared minus x. Good. And again, we started with all real numbers for everything here. And the same thing here. The shape of this is a cubic, so it looks like this. How far left and how far right does that crazy graph go? Yeah, negative infinity to positive infinity. So this is still just all real numbers for the domain. Now last one here.
Sorry, the way you wrote foil makes it look like fall.
Oh, fall has two L's.
Yeah, so without
Without an extra L, yeah. F-O-I-L. I don't know if that's better. Anyway. So D here we have f of x divided by g of x, which f of x is x squared plus x. G goes on the bottom, so that's 3x minus 1. And I can't do anything to clean that up. You might have to in Delta Math, though. Darn, I'm going to have to find one that you can do that. However, this one has a domain. Denominator has a denominator, and because of that, we have a domain issue. The denominator cannot equal 0. So anytime you see a denominator, you need to say to yourself, hey, denominator domain. I have a domain issue here. That denominator is not allowed to equal 0. Can I solve for x? How do you solve for x? Add the 1, and then divide by the 3. So this tells me that x is not allowed to be 1/3. And so everything else is fine, but x is not allowed to be 1/3. And the reason it's not allowed to be 1/3 is because if I plug it in there, 3 times 1/3 is 1. Minus 1 gives me a big fat 0. Okay, and I cannot divide by 0. So that's definitely something you want to look out for. Example 2 here. I'm not going to do all of this example. Right off the bat, though, I do want to talk about the domain. What is the domain of our f function here? How far left and how far right is it? Yeah, it's all real numbers. It goes from negative to positive infinity. It's all real numbers. It's that parabola shape. But what about the square root? What's the square root swoop look like? Oh, dang, I gave the answer. Swoop. It's the square root swoop. It goes to 0, 0, and it swoops to the right. Square root swoop, yeah? So what is the domain of our square root swoop? 0 to infinity. Yeah, including the 0 all the way to infinity. So this has a built-in domain restriction. It's only positive values, or 0, actually non-negative is how you say that, 0 and positive. And so when we put these two things together, if we're combining the functions, I can't use all the values. Here I can use everything, but if I put these two functions together, I'm limited by whatever the smallest group is, okay? So for instance, here on this first one, f plus g, we would have x squared plus 9 plus the square root of x. I can't combine anything there. That's what it is. The domain is whatever the smallest domain happens to be. So from 0 to infinity because of that square root in there. All right. So you always go with the smallest group there. All right. I'm not going to do any more of those. You're not going to see that in the Delta Math. So turn the page. Let's look at example 3 because that's more like what you're going to see. Example 3, we want to do g plus f. Watch your order here. Be a little careful. But first, I just want to talk about the domain. This is x to the 3rd power. What shape is that? A squiggle. Tall squiggle like that. Okay. And what's the domain?
Negative infinity.
Negative infinity to positive infinity. Yeah. All real numbers, if you will. All of them. And what's the domain of our g function? It's a parabola. So also all real numbers. It's that parabola shape. Goes forever to the left and forever to the right. Okay. So if we want to do g plus f, that would be g of x. What should I write first? X squared minus 4x. And then plus 2x cubed. 2x cubed. So g of x plus f of x. Oh, that's a cube. 2x cubed. There we go. Probably maybe 2x cubed plus x squared minus 4x. And again, when you look at this function, what shape is that one? It's a squiggle, the tall squiggle, yeah, the tall little squiggle. And again, that goes forever to the left and forever to the right, so it also is just all real numbers.
So you wouldn't take it
No. So, yeah, this is simplified enough. I mean, we could work harder, but it doesn't help it, yeah. All right, again, paying attention to order here. We want f minus g, so what am I going to do first? Minus all of minus 4x. So again, we're subtracting all of the g functions. So again, watch that negative. That's where all the mistakes happen. This is the third most common algebra mistake. So we're going to distribute the negative. We get negative x squared and a positive 4x. And that's actually just fine. That's in order. It looks good. And again, when we think about the shape of it, it's this giant tall squiggle. Good. So negative infinity to positive infinity for our domain. F of x times g of x is going to be 2x cubed times the g of x function, so times x squared minus 4x. Multiplying them together, and what do we need to do? Distribute, yep. Distribute those. 2x cubed times x squared is 2x to the fifth, very good. And then 2x cubed minus 4x. Negative 8x to the fourth. Beautiful. Do you know what shape this is? It's actually a more squiggly squiggle. It's sort of like that. Maybe. It's a more squiggly. So again, how far left and how far right does it go? Negative infinity to positive infinity. All real numbers. Yep. There are. They're called imaginary. All right. So then, f over g, f divided by g, we've got 2x cubed over x squared minus 4x. Now this one, in Delta Math, you need to pay attention. You are going to have to simplify your rational fractional ones here. So I see something I can do in my denominator here. Yeah, there's a greatest common factor. So I'm going to take out that x, undistribute the x. When I take out the x, what's left behind? X minus 4. And then on the numerator, we have 2x to the third. How does this simplify? What can we do to clean it up here? Oh, this is true. X is not allowed to be 0 and x is not allowed to be 4. This is true. From right here is where we'd want to think about the domain here, denominator domain. But we can also simplify as well, and Delta Math is going to want you to simplify. I have x times x times x on top, and here we have a times x on bottom. So you can cross out one on top and bottom. Yep, so this becomes a 2, and that goes away. And so that becomes 2x squared over x minus 4. So that Delta Math is going to want to see this. I don't think Delta Math is going to be asking you for a domain. But we always, the domain has to be the unsimplified thing.
So for the problem, could you plug in 0 now?
So, which is the problem with simplifying? Yeah, so when we simplify, we actually eliminate some potential problems. And it's our job at this level to know all the problems. All right, so we have to go from right here, right at the beginning, what was our domain issue? And we have to continue that domain problem throughout the whole thing. So that's sort of what we focus on in this class. So we're going to get really good at that. It gets really complicated when we have stuff like this, which I don't think we're going to do. Let's go down to number 6 here, example 6. I don't think you're going to get those in Delta Math. So here, given f of x and g of x, we want to evaluate each function. When you read that word evaluate, the root of it is value, which means that we want a number answer, all right? It shouldn't have anything with x's in it. It should just be numbers. And so what we want to understand here is the notation this is actually talking about. This is f plus g evaluated at 5. So this is really saying what's f evaluated at 5 added to the g function evaluated at 5. All right, what does it want us to do with the 5? Yeah, change all the x's to 5s. So let's see, I guess I'm going to do this in 2 steps here. I'm going to just figure out what f of 5 is. What is f of 5? F of 5 says replace the x with 5s. So 4 minus 5 squared. That's 4 minus 25. What's 4 minus 25? Negative 21. Good. And I'm going to figure out what g evaluated at 5 is. What is g evaluated at 5? It says 2 times 5 plus 8 is 18. And so if I want to do f of 5 plus g of 5, that would be negative 21 plus 18, which is negative 3.
You just plug it in.
You just plug it in, plug it in.
You don't have to find a domain.
Nope. And it wouldn't, the domain here that we're using is 5. X is 5. That's all. I don't care about anything else. So here, this notation, f times g evaluated at negative 2. So this really means, hey, what's f evaluated at negative 2 times g evaluated at negative 2. So again, I'm just going to go ahead and figure those things out. F at negative 2. Let's see, plugging in a negative 2. 4 minus a negative 2. Be careful. Watch your notation. We're plugging in a negative 2. Again, on like the next level of math, if you don't have this written properly, then you lose a point. Even if you get the right thing. All right, because you have to communicate the math. Someone's reading your work and interpreting it, and so it has to be written properly. This is negative 2 quantity squared. What is that? 4. Yeah, positive 4. So we have 4 minus the 4, which is going to give us 0. And that's just the first thing. And then g evaluated at negative 2. Let's see, that's 2 times negative 2 plus 8. 2, negative 4 plus 8, which is 4. And so now if I'm actually plugging those things in, f at negative 2 is 0. G at negative 2 is 4. And 0 times 4 is 0. All right, do you have questions for me? No? All right.